The file you've received.
The performer will give a simple demonstration of how you can map the data. The performer will now create a nice range for the data. Let's improve the smoothness. Let's control on and off.
Thank you. That was a very nice and simple demonstration. Now let us look at this in more detail. The motion sensor is an IMU that measures acceleration, rotation speed, and orientation.
We will now look at the data from each of these sensors separately. Let's first split the data into the different modalities of sensing. And then let's look at the data. We start with the gyroscope that measures the rotational speed. The data is in a very wide range, between minus 22,000 and 22,000. We should rescale this in a sensible way. Perhaps a bipolar exponential range is fitting. Not exactly right yet, but we can adapt it slightly with another curved range. That looks fine. Let's look at the accelerometer data. The accelerometer measures the acceleration, but is also sensitive to the gravitation force. Like the gyroscope, the data is in a very wide range, between minus 20,000 and 20,000. Perhaps we can use the same range mapping. That also looks fine. Then there is a magnetometer, which measures orientation in space based on the magnetic field. This range seems to be between roughly minus 5,000 and 5,000, so let's use a linear bipolar range. It seems to be clipping a bit. Let's expand the range slightly. Good. Now we have our 9 degrees of freedom. 3 for rotational speed, 3 for acceleration, and 3 for orientation. Now let's look at the buttons. It is not just nice to hit one button, but also button combinations are interesting to work with. The code that follows creates a binary number from the pressed buttons and stabilizes the pressed combination. Thumb, release, index, release, middle, release, ring, release, pink, release, thumb and middle, release, thumb and index, release, middle and ring, release, thumb and pink, pink, thumb and pink, release. We will now create a sampler instrument to start exploring real mappings. Let's start the sampler. 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 We will now look at the data from each of these sensors separately. We will now look at the data from each of these sensors separate from each of data from each of these sensors separate sensors separate sensors each of these sensors separate each of these sensors each of these sensors separate each of these sensors 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 sensors separate each of these sensors separate from each of these sensors data from each of these 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 the sensor start the sensor start the sensor start the sensor start the sensor sensor input sensor input sensor input sensor input sensor input sensor input
To the lab is connected 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 to the lab connected to the lab connected to the lab
thumb and index. Release. Let's add another sampler that is played when there is a big change in data on the gyroscope. Ring. Release. Big. Release.
Wide range between minus 22,000 and 22,000.
Nice to hit one button, but also button combinations are intricate one button, but also button combinations are interesting button, but also button internet, but also nice are intricate one button, but also button one button, also hit one just button content one button, but also button nice to hit one button, but also button nice to hit one button, but also button contact. Command index. Release. Command middle. Release. Thank you.